Now we can use our sum and difference formulas to find some stranger values, things where we don't even know the angles, okay? All we know are maybe a couple of values that we're going to use to find the others. So here, I don't know what S and T are, right? It says use the given information to find the sine of S plus T and the tangent of S plus T. Problem is I don't know what those angles are. They could be anything. But I do know that the cosine of S is negative 15 over 17, and the sine of T is 4/5. That's all we know, nothing else. And what we're going to be able to do then from that is to be able to find these two values, okay? We also know a couple other things. The quadrants that the two angles are in. That's only going to be important because we need to determine the signs of the trig functions, the positive or negative value, okay? And of course, we're going to refer back to ASTC, right? So that diagram will be critical as we finish this problem off towards the end here. So the first thing is that angle S is in the second quadrant and the cosine is negative 15 over 17. Well, let's hold off on the quadrant idea for just a moment and the negative. Let's kind of ignore the negative just for a moment. If I were to draw a triangle and put angle S in it somewhere, it doesn't matter, I don't even know whether that's the bigger or the smaller angle, I'm just going to draw it in here arbitrarily, then the cosine is always the adjacent over the hypotenuse. And so here I've got 15 over 17. I could use that ratio and just go with 15 on the bottom and 17 on the hypotenuse, right? That gives me the ability to find the third side. The third side of that triangle is found using the Pythagorean Theorem. And of course it's going to be the hypotenuse squared minus the other leg squared. Okay, so it's a squared plus b squared equals c squared, but if you solve for one of the other sides, you got to subtract the other side from it. And so it's going to be 17 squared minus 15 squared under that root. Now if I were to punch that into a calculator real quick, some of you may know this answer already, but 17 squared minus 15 squared is 64. And so this is equivalent to the square root of 64, which is 8. Okay, so that opposite side there is 8. In a similar way, I can work with angle T. I can throw that into a right triangle as well. Throw angle T in there. That's supposed to be a T. And I know that the sine is opposite over hypotenuse, so we'll go with the opposite side is 4, the hypotenuse is 5. Again, the bottom of this, the bottom leg here, would be found using the Pythagorean Theorem. And it's going to be the square root of the 5 squared minus the 4 squared. Well, 25 minus 16 is 9, the square root of 9 is 3. So this would be a 3, 4, 5 triangle with the bottom being 3. Okay, so now I can use that. Let's look at sine of S plus T first. Maybe I'll change colors just because I'm getting a lot of green up here. So let's go with the sine of S plus T. Well, we know using the sum formula for the sine that it's going to be the sine of S times the cosine of T plus the cosine of S times the sine of T if I switch my A's and B's to S's and T's, right? Well, then I can find all these things based upon the two triangles. So the sine of S is, opposite over hypotenuse, that's 8/17. But we've got to be careful because of the quadrant, right? So S is in quadrant 2, the sine is positive in quadrant 2, so I'm good with a positive value there, 8/17. Cosine of T, well, the cosine is adjacent over hypotenuse, it's 3/5. T is in the first quadrant, so everything's positive there. I don't need to worry about the sign on that one. Moving into the cosine of S, well, the cosine is, well, we already have that one. I don't even need to worry about the triangle, that's given to us, right? Negative 15/17. And then the sine of t, sine is opposite over hypotenuse, that's 4/5, and again, that one's already given. So again, I don't need the triangle, we have 4/5. And so from this I can simplify. 8 times 3 is 24. What's 5 times 17? 85? Yeah, 85. 24 over 85. This is going to be a minus, right? Because we've got the negative there. 15 times 4 is 60. 17 times 5 again is 85. And then I do the subtraction. 24 minus 60 is negative 36. Is that right? Yeah. Negative 36 over 85. Does that reduce? 85 is 5 times 17. Neither of those are factors of 36, so no, doesn't reduce. Negative 36 over 85 is equal to the sine of s plus t. Okay. Now, one other interesting note on this one is that the angle s plus t, what quadrant would that be in? Well, if you think about it for a moment, if you add a quadrant 2 angle to a quadrant 1 angle, so take a quadrant 2 angle and add a quadrant 1, seems like it's going to have to be in the third quadrant. Is that verified by the sine of the sine here, right? The sine of an angle is negative in the third and fourth quadrants. And so that does seem to make sense that it would be in the third quadrant. Okay. Let's take a look then at the tangent. So maybe I'll clear up a little bit of space here. Or do I? Yeah, let's do that. Let's clear up a little space. I'll just rewrite that as negative 36 over 85. Okay. Just to keep it up there. Now let's look at the tangent of s plus t. Okay, so the tangent of s plus t can be found by the, right here, tangent of a, or tangent of s, sorry. Tangent of s plus the tangent of t over 1 minus the tangent of s times the tangent of t. Now all these s's and t's all over the place with my sines and tangents gets confusing. I wish we used different variables, but I'm just going with what the book has because you'll see it on my math lab, I'm sure. So it's the tangent of s. If I look at my s angle, tangent is opposite over adjacent, so that's 8 over 15. All right, so let's see, let's write it horizontally here. So this tangent of s is 8 over 15. Tangent of t, again, opposite over adjacent, that's 4/3. Okay, so there's my two tangents on top. Then on the bottom I have 1 minus the product of those two things. Tangent of s, again, is 8/15. Oh, and I'm missing something, but we'll come back to it. 4/3 for tangent of t. What am I missing? Well, my negative sign. I gotta be careful. Angle t is in quadrant 1. Don't need to worry about it, everything's positive. But angle s is in quadrant 2. Quadrant 2, only the signs are positive, so tangent would be negative. So the tangent of s must be negative. That means this 8 is negative and this 8 is negative. Okay? Gotta be careful on the negatives. That changes things if you don't keep track of that. And I almost missed it, so be careful. Can fool anybody. So now we've got to combine these things. So I notice right away I have unlike denominators, but I can get common denominators here, right? 15 and 3. Multiply the 3 by 5. Top and bottom. That's going to then be negative 8 over 15 plus 20 over 15. That's the numerator. Yeah. The denominator, I've got a double negative, so it's 1 plus, and then I've got to multiply these. So 8 times 4 is 32. 3 times 15 is 45. All right, my numerator I can combine, right? Negative 8 and 20 makes, what, 12? So it's 12 fifteenths on top. On the bottom, I need a common denominator again, right? I'm trying to simplify a complex fraction. So I need to get a common, or a single fraction on the bottom. 1 is really 45 over 45. Think about it that way. 45 over 45 plus 32 over 45 is 77 over 45, right? Yeah, 77. So I want 77 over 45. Okay? When I have a fraction divided by a fraction, multiply by the reciprocal. Copy dot flip. So we do 12 fifteenths, that's the copy, dot, change it to a times, and then flip the bottom, multiply by the reciprocal. So it's 45 over 77. The 12 and the 77 don't reduce. I do like the 45 with the 15. I could also reduce the 12 and the 15, but let's do the 45, that'll be one step. Divide them both by 15, you get a 1 there and a 3 there. Nothing else really cancels. So 12 times 3 is 36. 1 times 77 is 77. I don't know why I hesitated there, but I did. Should be 36 over 77. It appears to be a positive value. Yeah. And that verifies that the angle S plus T must be in the third quadrant, right? Because if the sine is negative and the tangent is positive, the conclusion is that only quadrant 3 has both of those true, okay? So the tangent is 36, isn't that weird? 36 over 77, and the sine of S plus T is negative 36 over 85.